Welcome friends. Today I will explain about heat exchangers. Before going into our topic, I wish to discuss that how to learn. Hmm. Today we are seeing many things in this present world which are all discovered and developed by the persons who are lived in past centuries. They discovered this from this world's nature for humans comfort life. So now learning means we are trying to learn lively that how they discover these things from the nature. Example, one of the past centuries person kept a container containing water during afternoon session for some time. Then he took the container. mm, the water in it is heated. From this, the heat transfer is arrived. Then heat exchangers are discovered. Okay, now let me go into our topic, that heat exchangers. Generally, heat exchangers are device that facilitates the transfer of heat between two fluids which are at different temperatures. Generally, heat exchangers are classified on many bases. Let me discuss one by one now. First thing, on the basis of nature of heat exchange process, it is classified into two types: direct contact heat exchanger and indirect contact heat exchanger. First of all, direct contact heat exchanger. In this type of heat exchanger, both the fluids are mixed physically, due to which heat from one fluid is transferred to another fluid. This is what occurring in direct contact heat exchanger, and it is only applicable for immiscible fluids. Okay, what are the advantages of this type of heat exchangers? Construction is simple and it is inexpensive. The main advantage is that there will be no fouling problem. Fouling. Did you hear this word about fouling? It's nothing. If there is a heat transfer between two fluids, if we keep the wall in between them, it has to transfer to first wall and then to other fluid. Here, some deposits occurs in the wall which will reduce the heat transfer rate. This action is known as fouling. This is not occurring here. Okay, then disadvantages. Since both fluids are mixing here, mass flow rate also occurs. Main other disadvantage is that all fluids cannot be permitted in this type of heat exchange. Now, this is the general diagram for direct contact heat exchanger. Application: to preheat the power plant's boiler feed water, this type of heat exchanger is used, and during winter seasons, building space heating purpose, this type of heat exchanger is used. And pasteurization, what it means? It means nothing that for keeping at constant temperature, of foods. That is, food is preserved at particular temperature. This process is known as pasteurization. Then the another type is indirect contact heat exchanger. In this type of heat exchanger, both the hot and cold fluids are separated by a thin wall. Then assume that how here heat transfer occurs. First of all, from one fluid to the wall's one side through convection process. Convection. Here what the convection means. In order to understand this convection, we will slightly go into the modes of heat transfer. Generally, there are three modes of heat transfer: conduction, convection, and radiation. Conduction refers the heat transfer to a particular material or particular state, example solid. The heat transfer through the solid. For best example for conduction is heating of iron rod. If we heat at one end, it will be transferred to the other end. It is one type of conduction. Then convection. Convection means heat transfer between two different phases, that is from liquid to solid or solid to gas or solid to liquid. In between these different phases, if heat transfer occurs, then it is named as convection. Radiation is one type of heat transfer. It does not require any medium, that is, it is a mediumless transfer. Generally in heat exchangers, radiation will be neglected, only conduction and convection are considered. That's why here first one fluid to walls one side convection occurs, then through this wall conduction occurs, then finally through convection process it reaches the another fluid. This can be classified into two types: indirect type, regenerator and recuperator. Regenerator, okay, see this diagram in the screen, that there is a circular fan at the center, and this circular cylindrical section is divided into two halves, that is, at upper of one fluid is allowed and bottom of another fluid is allowed. If this fan rotates, it will absorb the heat from the hotter fluid, then it will be passed into colder fluid. This is how heat transfer occurs in heat regenerator. The other type is recuperator. It is a normal heat exchanger, that is, there will be one outer shell, inside it there will be one tube. Through shell one fluid will be passed and through tubes another fluid will be passed. Due to difference in temperatures between two fluids, heat will be transferred from one fluid to another fluid. Okay. Now on this basis of direction of fluid flow, heat exchanger is classified into two types. One is parallel flow heat exchanger and another is counterflow heat exchanger. First of all, we shall discuss parallel flow heat exchanger. In this type of heat exchanger, the direction of fluid flow will be same, due to which it requires a more surface to transfer more heat. But normally it will be there will be a less surface, hence it is rarely used. But in case of multipass, it is unavoidable. It maintains a constant temperature at the wall surface. How this is maintained? You can visualize that if the both fluids flow in the same direction, then it will be maintained constant temperature at its wall. Then applications, parallel flow heat exchangers are generally used in water heaters and oil coolers. Next, now look at this graphical plot. Here the length is taken along x-axis and temperature is taken along y-axis. You can see that hot fluid temperature will be decreasing and cold fluid temperature will be increasing. This is the general plot. And this, look at this heat exchanger diagram. Here the direction of two fluids will be same. Okay, now we shall go into counterflow heat exchanger. Counterflow heat exchanger, as its name indicates, that here the direction of fluid flow will be in opposite. Hence, due to this reason, here the heat transfer is more when compared to parallel flow heat exchanger. And one of the main advantage or main point you should remember that counterflow heat exchanger is that the heat transfer or heat the temperature difference throughout the length of the heat exchanger will be equal. This is the counterflow heat exchanger general diagram. Here you can see that both are moving in opposite direction. Then crossflow heat exchanger. It is also classified under the basis of direction, nature of direction flow of cross flow means the tubes are arranged perpendicularly, that is perpendicular to each other. Now different fluids are allowed in different tubes. Hence, due to this reason, heat will be transferred from one fluid to another fluid. It is of two types: unmixed crossflow, mixed crossflow. Mixed crossflow, it is generally take a one tank like container inside which many tubes will be there. This arrangement is known as mixed crossflow. Unmixed means both in horizontal direction and vertical direction. Both are tubes, hence there will be a no mixing will occur here. Both the fluids will move in different tubes. This is the cross flow heat exchanger. You can visualize here. This is of unmixed type. That means here the tubes, you can see the pink colors tubes, and on another side you can see that both are perpendicular to each other. This is the, you can understand this type of heat exchanger by looking at this diagram. Then on the basis of design and constructional features, heat transfer is classified into four types. First of all, compact heat exchanger. The name compact indicates that the size of the heat exchanger will be small, but we can attain all the features we want. That is, in this type of heat exchanger, the surface area per unit volume will be large. Okay, I already said the advantages. One more advantage is that high heat transfer rate will be there in this type of heat exchanger. Disadvantages: since it is compact in design, it requires a high initial cost. Here the fluids are pumped through a pump, hence here there will be a more pressure drop. This is the compact heat exchanger general diagram. Then concentric type heat exchanger. Name itself indicating that concentric. Here the two pipes which are arranged in concentric manner Different fluids are flowing in different pipes, hence the heat from one pipe to another pipe through convection, conduction and convection method it will be transferred. Here itself you can see that how the setup will actually look like. Then one of the important heat exchanger, shell and tube heat exchanger. This also we can visualize by seeing the name itself. Here will be a shell and tube. You can better understand by viewing the picture. This is the shell and tube heat exchanger. Here it is a shell and tube. If one fluid is allowed in shell and another fluid is allowed in tube, due to which are both the fluids are at different temperature, hence from the hotter fluid heat will be transferred to the colder fluid. Here you can see that baffles. What is the purpose of baffles? They will increase the heat transfer rate and also reduce the vibration to support the pipes. Okay, this is commonly used in industries and it will not be suitable for automobile or aircraft due to its high weight and large in size. Then multipass shell and tube heat exchanger. Multipass, the same it is same like a shell and tube, but here tube will be passed at multi time, that is there will be more passing of one fluid, that is which is flowing in the tube inside a shell. You can understand it by seeing its types. One shell pass, two tube pass. Listen carefully here. One shell pass. It means there will be only one shell and two tube pass. It means there will be two U-like tubes features in this. If we look at the two shell pass and four tube pass, there will be a two shells and four tube pass. That means you can look like four U creature or U design in the inside the shell in tube arrangement. Generally even number of tubes will be there. Advantages: helps to lengthen the time and more surface, hence there will be a more heat transfer rate. You can see here, I will explain better here. Okay, this is there you can look at the shell. The whole tank look like structure is the shell inside which a tube is passing. Here this is multipass. Here you can see that totally how many U like design in this tube. You can count this 1 2 3 4 5 6 and 7. Here totally 7 tube pass is there in this type of multi-pass shell and tube heat exchanger. Okay, and this is the final way of classifying the heat exchangers based on the physical state of fluid. Physical state, it tells us to think that physical state, that is liquid to gas or gas to liquid, that is first of all condenser. Condenser name itself indicating that there will be a condensing occurs here, that is the here the fluid is enter into the tube will be initially at gaseous state. Here, finally at outlet, it will be converting into liquid state. Mostly shell and tube type heat exchanger will be used as a condensers. Application: R and AC. What it means? R refers refrigeration and AC refers air conditioning. Air, in this R and AC parts, condenser is one of the part, and you all know that in thermal power plant, condenser is one of the key part. Without condenser, the power plant's Rankine cycle will not work. Then finally, the evaporator. It is one type of heat exchanger. Here the fluid entering the tube initially will be a liquid state, and finally it will be at outlet as gaseous state. Application: normally in chemical industries, it will be in chemical industries you can see the evaporators, and normally in refrigerator you can see that evaporator is at the back of the refrigerator. Food processing industry also contains the evaporator. Okay, thank you. I think you understand about the heat exchangers better. If you have any doubts, please comment it. I will explain clearly once again to you. Okay, thank you, and subscribe this channel to get more knowledges in mechanical field, and also click the bell icon to receive my video daily. Thank you.